Hi, in this video, we're going to continue with question 5 from the 2025 KZN trial paper 2. And our focus in this one is 5.3. So, the question reads, given cos 3 theta plus cos 7 theta all over cos 5 theta is equal to 2 cos 2 theta. And the question is a trig identity. And the question says prove the given identity. So on inspecting the question, and we're going to start with the left hand side. Now if I look at the denominator, which is a single term, it has a 5 theta in it. So I'm going to write the 3 theta with a 5 theta, which would give me 5 theta minus 2 theta. So if we rewrite cos 3 theta, it's going to give us cos of 5 theta minus 2 theta. Then I'm going to look at the 7 theta. And we know, trying to match the denominator of 5 theta, we can write 7 theta as 5 theta plus 2 theta. So we're going to rewrite the cos 7 theta plus cos of, instead of writing 7 theta, we're now going to split it up and say it's 5 theta plus 2 theta. All over the denominator of cos 5 theta. Which is now equal to, so if we look at the top, cos of 5 theta minus 2 theta, that is actually a compound angle. And if we use our compound angle formula on that, we would get cos 5 theta cos 2 theta. The minus would change to a plus sine 5 theta sine 2 theta. If we look at the other one, which is cos of 5 theta plus 2 theta, once again, we're going to use our compound angle formula, and that will change to plus cos 5 theta cos 2 theta, and the plus will change to a minus sine 5 theta, and I don't have space, so I'm going to write it down, sine 2 theta. All over our common denominator of cos 5 theta. Now, if we inspect the numerator and look for like terms, you'll notice we have, and I'm going to take out a highlighter. So we see like terms. So we got 2 of cos 5 theta cos 2 theta. So we can rewrite that as 2 cos 5 theta cos 2 theta. And then we continue to look for like terms. And you will notice that sine 5 theta sine 2 theta, that's a positive, with the negative will cancel off. So we're left with what you see on the numerator, and that's all over cos 5 theta. And then you'll notice that the cos 5 thetas will cancel off, and we're left with 2 cos 2 theta, which is actually equal to your right hand side, because that is what they actually want us to prove, 2 cos 2 theta. There's a second part to this question. So remember, we proved the identity. The second one is, it says 532 hence, which means use the fact that this has been proven. Now you can determine the value of cos 157.5 plus cos 67.5 all over cos 112.5. So we need to find a link. The link between that and that. And if I inspect that, the denominator has cos 5 theta. And this denominator that you see here has cos 112, 5. Now I would like to write this as a 5 theta. So to be able to do that, I'm going to take my 112.5. And if I divide that by 5, that will actually give me 22.5. And then I'm going to say now, let theta equal to 22.5. Now, how is that going to help us? So if we now take the expression and we rewrite it, remember, cos 112.5, remember I divided that. 112.5 divided by 5 gave me 22.5. So that means I can rewrite 112.5. If that's representing theta, that now becomes cos 5 theta. Then on the top, I got cos 157.5. And if we take the 157.5 and divide it by 22.5, you can use your calculator, 157.5. And if you divide that by 22.5, which is now representing theta, that'll give you 7. So that becomes cos 7 theta plus, then we have cos of 67.5. And if we take 67.5 and divide by 22.5, that will actually give us 3. So we can rewrite the cos 67.5 as cos 3 theta. Now, which is the same as what is given on the top. So that means that that given part was equal to 2 cos 2 theta. So we can rewrite this as 2 cos 2 theta. But remember that we let theta to be 22.5. So now this becomes 2 cos 2 of 22.5, which is equal to 2 cos 2 times 22.5 is 45 degrees. Now cos 45 is a special angle, and cos 45 would be root 2 over 2. And we'll now cancel off the 2's, and we're left with root 2. Thank you.